So now comes into like the fun stuff, right? Our visualizing our data. So first thing we can do is take our data and actually show changes over time. So this is a new data set here. Note that this is going to be New York Stock Exchange. So just kind of quickly looking at what that looks like. You can see here we have the month and then monthly returns. So these are relatively simple data sets, but for the most part, we're just going to focus and note that this is going to be a month now. So you can see here is that we're not going to have, what's it called, any daytime or date. We're just basically saying, okay, like what's that month? So you can see 1961 February, 1961 March, and so on. Okay, so let's go back to our intro. Okay, and you can see here, we're going to read that data just like we do normally. We're just going to have a column name called month, so we're just naming it in there for ourselves. And then we're going to convert to date time. So we're going to convert that column, which is month. Okay, I'm just kind of specifying here. And we're going to say, okay, convert that over to a date time, save it under that column. And then we can actually see set the index. I note that we put in place, because if I didn't put in place, it would make a copy of it. And then we can now see that we have our nice little month here. So note that because it's a date time, right? Note that there's that 0, 1 in here. So this will, because the date time can't just simply have a month, it has to have a day as well. This will be 0, 1. You even got to guess what the time would be, because a date time, as you might guess, you have the date and the time. What do you guys think the time will be by default?
It would be 12 a.m.
Yep, that's right. It'll be 12 a.m. essentially. And I think it goes by default Greenwich GMT. So Greenwich mean time, median time. Anyway, GMT. So like UTC like 0. So just to kind of be aware of those kind of things. That can give some issues if you're not careful. So just know that by default, it'll go by January 1st, or sorry, January 1st, the 1st of the month. Okay, so cool. So now we got this data. Let's actually plot it out, right? So what's nice is that we can actually just plot this out directly. Note that we're just taking the data frame, NYCS or NYSE. We can just plot it out. This figure size, just remember this is just for any plot. You can decide how big the figure is. And if I do this now, you can actually see a time plot. So just know by default, because our time here, and you can see this right here, okay? And we'll just have our different values go through. So what's nice is that this is typically what you might see in a time series because these are connected values. Usually they affect each other. Note that line plots are not always the best way to display data, but a lot of times for time series, because usually the reason why we care about the time series is that the previous day affected maybe the next day and so on. So you might have an effect going forward. So you might want to look at actual, what's it called? The actual like connection between these two. Okay, so kind of similar is our dot plot, right? So you can see is that we can do the same thing, but in this case, we just change the style. So this is more like matplotlib arguments that we can put in here. So we can do this guy. And you can see is that we also have the same data here, but between these two, which do you think would be most relevant in giving us information about a time series? A dot plot or a line plot? I see some lines kind of like going line. Yeah, so good. And can someone explain to me why a line plot? I think you guys intuitively know, but can someone verbalize, you know, why would a line plot be probably more desirable than a dot plot in most cases for time series?
I think it's easier to see a trend.
That's right. And
up or down.
yeah, so you can see that trend. And that's the thing is that you want these points to be connected. With a dot plot or scatter plot, you know, however you want to phrase that, is like really what you're looking at is just saying like where are the different distributions in that sense. But with a time series, you really are talking about like a progression through time. So it makes sense for those to be connected because they are connected from the previous date to the current date to the future date, right? So a dot plot, scatter plot tends not to be as common for a time series data set. Okay, cool, good job. All right, and then note that we can also plot them in groups too. So if we wanted to look at things like a year to year, temperature throughout the years, we have a couple options to choose from. So kind of showing you a few things from curriculums. I kind of pulled data sets that are relevant to what we've seen, or not data sets, but code that we've seen from curriculum. So as you go through the curriculum, if you haven't done already, you'll see these kind of come up, is that we can group our years. So note that we have our data frame. We can do a group by, and then note that this right here basically just allows us to do a frequency A. And we've got to guess what A stands for. For annual, A for annual, right? So this will be group it by years, right? So note that it's like, how do I know which one to do? You would just look up this part right here and check out grouper and see what things you can group by and stuff like that in examples. So in this case, we're going to group it by year. And what's nice about this then is that now we have a data frame that's going to be grouped by year, just like you would group by anything else in a data frame. Okay, but remember the focus here is that it's date time, right? And note that we're going to have an annual part here. Let's see if I want to make sure I got this right. Yeah. So we're basically going to look at this annual return. And so we're basically taking out the year and then the actual group. And that group is going to be all of those data points for that year, right? And basically this part, just .ravel, basically it will allow us to make it so that group by data frame will be connected into just a year by year basis. So this way we can look at just 1 year at a time, okay? And so if I plot this probably makes more sense if I actually plot it, is that you can see here is that each plot now is being plotted out by each year. So note that that's what the difference is right here, is that this group is basically pulling up those values and only pulling out. I think Ravel might be a good example of like kind of like the way it's phrased. It's like you're unraveling or raveling up of saying, okay, just this segment of that group. So you can see, we can plot these out all together. So now we can see, instead of all of this info, let's move this a little smaller. No, I can't make it smaller. Instead of having all the data right here going from 1961 to 1967, which is hard to see, like, is there a trend per year kind of thing? Like we can see an overall trend, but maybe not specific per year to year. This might make it a lot easier to actually look. It's like, okay, like, you know, do we actually see a trend for going from the beginning of the year to the end of the year? Okay. Any questions or any comments? Cool. All right. So note that we have basically plotting each part. Why maybe some issues about this? Like plotting on each individual part. Is this easy to see? Yeah, I see some head shakes being like, no. So can someone verbalize, like, you know, what makes it a little bit difficult for us to like pull any information out when it's plotted out like this? So I'll give you one minute.
You don't know if the scale is the same for every...
That's right. Good. So yeah, if you're careful, you realize, oh wait, there's different scales, right? So now it looks like they're all the same. You can get the idea of like, oh, maybe these ones tend to start at the top and like go towards the middle part, maybe not the smallest, but the scaling is going to be off, right? So you can't directly compare each one, right? Another aspect too, even if the scaling was the same, it's kind of hard to compare like something like this to like the next one down here. Let's say assuming like the scale is the same. It might be kind of hard like going back and forth, like, you know, looking at this one and looking at that one. You might get an idea, but this is only 5 years. Imagine if you had like 10 years or even 20 years and all stacked on top of each other. It'd be really difficult to see what the overall trend is, right, amongst those years. So another example of this is essentially we can group them all together. So in this case, note that it's pretty much the same thing as plotting here, but we're plotting out the grouped data frame, right? So note that the MSE annual has already been grouped over here. Okay, so these are all still grouped together essentially. But when I go ahead and plot these, I can actually plot them as, instead of subplots like you have right here, okay, I can actually plot them all together. So what happens is that we can actually see them all together. And in this case, I don't know if you can maybe argue, say, oh, you can see a pattern, maybe you can't. But in some cases, you might see this might be a little bit easier. So you can see all of them together, like, oh, going from the beginning, like January, all the way through like December, you might be able to more easily see a pattern going through here. So I'm going to make up some stuff. I don't know if this actually exists, right? But things to look out for. It's like, oh, like, you know, we definitely see things tend to start up maybe a little bit higher in the first month. And then as we kind of go throughout the year, they kind of level out. They don't quite hit minimum, but they definitely go a little bit lower. And then maybe they rise up the next year. It's like, maybe that's a trend that we're in there. Okay, so you can see those distributions a little bit easier. Okay, however, this is probably still not the perfect one, right? You can kind of see like it's still a little tough to see. Maybe there isn't a pattern in there. Maybe there is. So there's a few other ways we can do this as well. Okay, so showing some extra distributions, stuff like this. So other ways to explore this information. So I'm going to show you main ones are like histogram and density. Then we'll see box plot, and then heat maps is one of my favorites in the sense of showing all this information together. So what are the reasons like we would actually do this? Well, one is we can check for normality and see basically from this distribution, like a histogram or density plot, to say, are the values actually spread out normally distributed and everything. And we can actually check on like, raw and transform data. So we can check our data before we transform it. And if we need to transform it, we can transform it after and check that normality assumption. Okay. So histogram, note that we're basically grouping them together in this case. So we're just looking at the actual value. So note that this is not specific to, this is no longer time-centric in that way. We're just looking at for each month, how many fall within, what's it called, this range. So like, okay, like we have 4 of them that fall within the range of about 0.06 to 0.05, right? So that means 4 of them fall in this range, and this collecting them through. So you can see like, is there a normalities spread? This might be important depending on certain tests that you're doing or looking for specific or using specific statistical tools. You might want to see, is the data actually normally distributed? Maybe it's uniformly distributed. That might be an important aspect to know, okay? This is kind of like not super clear in that sense. Well, like not super clear, but like this was automatically decided since I did a histogram. I didn't specify the bins. So note that we can specify the number of bins. So for example, if you know that there's going to be a certain set of bins or you want to group them together, you can see here there's 7 bins. And even though this is the same data, it might be a little bit different on how you spread it out. I could do for technically, let's say 17 bins, right? And you get more fine-grained data. It depends on your situation on what this bins would make sense. So just kind of be aware of that stuff, but you can adjust it in this way. And this is a good way to visually check if there's normality. Okay, cool. Any questions on what's going on in this histogram? Okay, good, cool. So next part is basically our density. So similar to a histogram, right? We have our KDE. Does anyone remember what KDE stands for? I'll tell you the D stands for density.
Kernel density estimate.
Perfect, right? So whatever that means, right? So our density, right? You can think of it like our histogram, right? Saying like, where is it concentrated? Is there a lot density, like density being like, is it towards the middle? Our estimate meaning that it's not going to be literal like the histogram is, right? It's going to be estimated. We're going to draw, essentially that estimate means that we're going to try to draw a nice smooth line for our data. Now that line doesn't actually represent our data, but it might help us represent. The kernel part, basically, that K, basically is saying, how do you estimate this? If you remember, I don't know if you guys remember, it was like maybe back way in mod 1, where I showed you guys statistical distributions, and I showed those little tiny Gaussians added up together. That's what our kernel is. Basically, it's saying, oh, we're breaking up into little parts and we're adding them up all together. So that's what that kernel part represents. So we can see this, we will see a nice smooth trend. And you can see here is that we actually have this histogram right here. And this is basically trying to make it nice and smooth. If I had it, let's see here, 0, 10, okay, it's a little off. But you can see here is that this is not literally how the data looks like. But you can see there's a reason why there's a little bump here is because it does raise up, but it does kind of go down and then back up. This is coming from this guy right here. It's coming up and then going down a bit and then coming back up again. So that's where this kind of shape is going through. So this is a more like organic looking shape versus like our blocky histogram. So this can also help us kind of visualize a little bit like what the data might look like if we upsampled or try to do this experiment over many, many years. Maybe this will be closer to what we'd actually find. Okay. Cool. Any questions on this KDE? All right, cool. And remember, we're just looking at basically the spread of this. Okay, so something similar going through is like we can actually look at box plots, right? So this is kind of cool because we can actually help show outliers. So remember, box plots are going to represent our range, our values, right? So we're going to represent that box as our inner quartile range, right? And then those points outward basically extend out to the rest of it. And then we might identify outliers. Basically, I think it's defined as 1.5 outside the interquartile range. So if your points are at 1.5 outside the median of the interquartile range, basically those are seen as outliers. So that can be really useful. But you can also see some trends too, is that because everything's going to be, how do I say, like there's certain factors that might move it up and down, the box plot can kind of give us a more spread out value versus like a single point. And it might be easier for us to see if there's an actual trend. So best thing to do is just see an example. So you can see here, I still have that grouped annual part, and we can actually do our box plot. And you can see here, here's our box. So you can see basically for each year, right, 961, 962, 963, you can see that each one of them tends to be like maybe there's a little bit of a change going downward, upward. But what's really important, probably sticks out to you the most, is that you can see that 964 and 965 definitely have a much smaller range of values. So you can see that there wasn't as much variation between these different years and stuff like that. And maybe there's a reason why in this, maybe there's not. But maybe, for example, these years correspond to something that's less volatile. Remember, we're looking at the New York Stock Exchange. So maybe values didn't really change that much throughout the year. Versus 1961, they had a maybe much more volatile year for these past two. And you can see it kind of calm down over here. Over here. So you can see you start building a story a little bit of what's going on. And note that this is, again, this is why I always emphasize like visualizations. Your visualizations are trying to look at like your elephant of data, and you're seeing different aspects of that elephant, right? So our box plots are showing one thing versus our line graph, which shows us more like this change over time. Okay. So our last one, which I think is a really useful one to go through, is a heat map. So we can use color to show patterns through time period. So kind of going back a little bit way over to this one, this is like kind of a messy data set. It's a little tough for us to see exactly what's changing and stuff like that. So we can actually use color to help emphasize what the shape changes. So we'll see a little bit of this. So in this case, I'm actually using temp annual, so actually getting a lot of data. This really helps when you have a huge amount. So just to show you an example of, you know, different ways to plot the same data. Right, so we're going to do temp annual, which I believe this is coming from that one with the different temperature per, I think it's per day, the different per day and everything like that. We're going to still group it by annual, right? So we're going to group them all together like that. So note that I'm using that same procedure here. Okay. And then I'm going to plot each one in a subplot. So using our strategy, we're plotting multiple lines and see if there's a pattern. So you can see when I do this subplots equals true, you're going to see a bunch of plots. And you can see here, this is going for every single day, if I remember this right, for each year. And I don't know, looking at this, can anyone really see a strong pattern in any given thing? It's tough, right? Like maybe there's something there, like I don't know what happens, but like in my mind, like this seems like similar stuff, but the scale's off, there's not a clear pattern, stuff like this. So maybe it's not super helpful by itself, right? So like I said in here, past Victor put down, you have a hard time seeing exactly the temperature shift, right? So we would expect there to be a different temperature throughout the year, right? So we imagine in the winter time, which is probably around January over here, and then, you know, December, to have lower temperatures, and it probably gets higher somewhere at some point. You know, maybe that exists. Maybe my dates are off or something like that. I can't really tell. So there's other ways we can plot this together. So one way we could plot was plotting all of them together. So all we have to change, well, let me ask you guys. We have here our different subplots. How do we make our graph so it's all together? So it's one big plot on top of each other. Does anyone remember what we did, or what was the one thing we changed?
Like where it says subplots, false.
Yeah, that's right. So that's what I have done here. So you can see subplots equals false, same exact thing. I changed the figure size just to make it a little bit easier for us to read. So I'm going to write this now. You can see, okay, cool, right? So it's still a huge mess, right? Like you can't see every individual, but at least now we can see there's like on the same scale, so that there's definitely a change going from, you know, higher temperatures here going down and up. So if this is corresponding to January, this might, for example, be representing maybe like on the southern equator. I don't know, like that's my guess of like why it's hotter here. But the point is that we can actually see that pattern overall, where again, I like to emphasize, this is the same data, right? But it's telling a very different story. And that's where your visualizations basically are, these explorations can be really useful by themselves. Doing this, something like this, for example, can be really helpful for you to find like, oh, there seems to be a pattern in here. But it can also be really helpful to maybe show this pattern to a stakeholder. This by itself, to be honest, let me ask you, would you guys, how would you maybe modify this to present this to a non-technical audience? Like what things might you try doing? And there's no wrong answer in this case. I'm just kind of curious to think, trying to get you guys to think a little bit on how you could change this to make it more digestible.
Use less data points for sure.
Yeah, so maybe use less data points. Maybe, for example, use it every month versus every single day of the year. That might be helpful, right? So that hopefully should still show you a trend going forward and stuff like that. I think that's probably my instinct. I probably would do something along those lines. If you really wanted to simplify it, you could maybe make a smoother transition. So we'll talk about something called the moving average, where we can actually plot out an average going forward, and then kind of smooths out this curve versus like you can see each day being very jagged. You can actually smooth this out a little bit. That might help a little bit too. So there's a few things we can do. So this is good. We can actually see there's a decrease in the temperature, right? But there's one thing that it kind of stinks in the sense that like we can't see any individual date. Like, can you tell me like 1987 how the temperature changed and like how it deviated from this overall trend? No, right? Like there's no way you can see that, right? You can try seeing like, oh, it looks like there's like 1987 right here and then like disappears in the fold, right? Like we kind of sacrifice in a lot of ways looking at the individual data versus like something like this. So one way to kind of compromise this is something called a heat map, which I think is hilarious that heat maps work well for this temperature data. But anyway, if we check this out now, note that we're basically taking our temperature annual. Note that this dot T, what does this dot T do? Does anyone remember? I think linear algebra.
Transpose.
Transpose, good, right? So note that there's a few ways we could do this, but basically we're transposing it. So we're essentially flipping it on its side. So this will make it easier for us to actually plot it out. And then this plot.mat show. So note that this is a matplotlib function, right? So mat show, mat meaning matrix, okay? We're showing this, the year matrix. We're doing interpolation equals none. So we're not extending it out since we have all the data there. We're doing aspect auto. So that just makes it, I'm making these explicit. I think these are actually the defaults. And then our CMAP is our color map. So note that we're basically using a very special, we're deciding which color to use. So this is really important, especially if you are thinking about people who are colorblind, right? You don't want to use red and green for someone showing your changes in a range and a heat map. Also, I will say is that generally you don't want to use, which I see so commonly, is use the full spectrum of the rainbow of for hot to cold kind of deal. The reason why is because it gets in this weird spot where once, people who are colorblind can't tell the difference between red and green, on top of each other. So that's kind of tough. But also that huge spectrum, it's kind of tough to tell exactly like what is hotter or colder when you look at just hues by themselves. So generally you want like one or two, like 2 to 3 colors really changing in hue. So just know that I use this color map here just to show an example. So you can see here is that now we actually have red. This is kind of going on green, so I'm kind of breaking my rule here, but it's kind of closer to the blue in this case. So you can kind of see going forward is that what's nice is that we're actually seeing every year here. So 0 to like 9 in this case are all these different years going forward. So what's nice is that I actually still preserve each of the pattern of the information here going from like relatively hot to colder and then back hot again. But what's nice too is that I also get the full spectrum of this thing. You can see that it tends to be hot in the summer here and then, or I'm assuming it's summer, right? But like hot in this time of the year and then cools down at this part of the year and then heats up again. And that's an overall trend too. So this is where you can basically use different patterns to kind of like show the progression of like our time going forward. And note that this is the same data as we showed like going for just a full line chart, right? So this again is like how you can display the same information and still display stuff and try to find the patterns that are in there. Okay, cool. Any questions about for making any of these kind of graphs, whether it's the heat map or different plots like this? Cool. Sound good? Thumbs up? Cool. I just like this graph. It's so pretty, right? So